Hello everyone, welcome to the live class. So guys, today we are going to have another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR net and the GATE physics exam. So I hope that the discussion which we will be doing today in the session will be getting clear to every one of you. But in case if anywhere you will have any doubt, you can surely let me know about it and we will try to consider those points here in the session. So guys, I'm just going to continue the discussion and I'll be sharing some important slides with every one of you. Okay, first of all, and then we will be continuing the discussion about the important questions and the concepts we will be considering in this session today. So first of all, I'm going to show you the slide regarding the latest offer which is going on Unacademy. As you can see here on the slide, we are going to have the important details about the latest offer, as per which you will be able to get flat 20% off on CSIR UGC net subscription. The offer is just valid from 16 to 21st February. So in case if you don't want to miss it, you can take your subscription now and use and apply the code that's Anjali Live as mentioned here on the screen. So this is how guys you will be able to grab this offer, and even if any of your friends want to take the subscription and you want to let them know about it so that they can even get this benefit along with so many important benefits they will get depending on which subscription they will take, so you can let them know about it too and they can start their preparation under the guidance of top educators as well. Clear? So now I'm going to show you the slides which will help you to know about this part, that if anybody will be taking iconic subscription, then what are the benefits they will be able to get. If anybody will be taking the plus subscription, then what are the benefits they will get. Even now we are going to have the let me just tell you, just a second. Even now we are going to have the notes available on the learning app which will be helping you to take your preparation to a very good level. So guys, you can take the subscription and you can start your preparation under the guidance of top educators. In upcoming days, so many new courses by the top educators will also be starting on Unacademy. So to grab the offer, what you need to do, you can use and apply the code that's Anjali Live as mentioned here on the screen, and you can grab this offer which is even going on right now. This is about the light subscription, and the difference between the Unacademy Plus iconic and the light subscription have been shown here on the screen. So I hope each and everything is getting clear to every one of you guys. And here we are going to have the another important information about the community feature. So what are the benefits you will get? Okay, along with that, if you take the subscription, and you are going to get the updates regarding the new latest information on community tab in Unacademy learning app. So this is how even you can stay updated. This is something about me. Then we are going to have the details about the like session today we are going to have, and the important slide regarding the subscription. So let's continue the discussion now. Let me just take the important questions and concepts here. At any point of time, if you will have any question, query or doubt, you can surely let me know about it and we will try to consider that. And at any point of time you will be proceeding further to take the subscription, then you can use and apply the referral code that's Anjali Live as mentioned here on the screen. So I hope now each and everything is clear to every one of you. Very good morning, Vikram. Very good morning, everyone. Yes, Vikram. So now let's talk about the questions we will be taking here. That's going to be the important concepts of electromagnetic theory based questions I'll be considering here. Okay. At any point of time, if you will find like there is any doubt, you're gonna have something you're not able to get, so surely let me know about it and we will be talking about that point too. Okay, let me just give you the first question for this session. Just a second. I'll be writing the first question here. And the questions will be based on different concepts. So let's go through that. Let me just write the first one first of all. A static spherically symmetric charge charge distribution is given by, that's going to be rho r is equal to a by r e to the power minus kr, where a and k are positive constants. The electrostatic potential corresponding to this charge corresponding to this charge distribution varies with r as options are r e to the power minus kr, then option B is 1 upon r e to the power minus kr, then option C is 1 upon r square e to the power minus kr, and the option D is we are going to have 1 upon r 1 minus e to the power minus kr. You can start working on it. If something will not be clear, you can surely let me know about that. But if everything will be clear, that's great. You can start considering the steps you think you have to take and tell me what will be the right answer according to you. We can consider that part. Okay, so whatever will be the right answer according to you, let me know in the comments. We will be talking about it. But if there is any doubt at any point of time you will have, you can just mention it. So let me know whether everything is clear or is there any doubt. Clear? Giving you some time to work on this question and let me know that what you are gonna get, and just in some time I will even start the discussion about it. Clear? Mhm. So waiting for your reply for some time, and then we'll be starting the discussion too. So they have given a static spherically symmetric charge distribution is given by, that's rho r, which is equal to a upon r e to the power minus kr. Okay, now where a and k are positive constants, so charge distribution is given, that is the charge density has been given to you, and since it's the sphere means a spherical system, so it will be volume charge density we will be considering here. Then we have to find the potential. So is there any formula which relates the charge density with the electrostatic potential? We know about the Poisson equation as well as the Laplace equation. So in the Poisson equation, you are going to have delta square V is equal to minus rho upon epsilon naught. Rho you can write there and you can get the V from this equation. So that's how you can consider it and you will be able to get your answer. But in EMT part, the coordinate systems are going to be very much important. So if you will see here, we have to consider the spherical symmetric. Okay, so spherical coordinate system we have to consider. In that case, what will happen? When we are going to talk about the spherical coordinate system, we have to see that what is going to be the Laplacian expression as per that system. Clear? These are the steps you have to take. Delta square v is equal to minus rho upon epsilon naught. Now let's just consider the Laplacian in terms of a spherical coordinate system. And once you will be considering it, what you have to do next? That's going to be that it's gonna have just the rho r, which is the function of r. So what you will do, you will have to write it in terms of r only, the Laplacian. Clear? So once you will be writing it, what next you will do? You will not be considering the phi and theta parts there, because you don't have that function present. Even in the options, if you will see, it's not there. Okay, and in the given rho r expression, it's not there. So what you have to do, you have to consider it that way, and that's how when you will proceed for finding the v value, you will be able to get the right answer. If there will be derivative terms, you will have just remove the derivative from one side and take the integration on the other side, and that's how the further simplification steps you will keep on taking. Still, if anybody is going to get the answer, just mention it in the comments that what is going to be the right option according to you, whether it's option A, option B, option C, or D. Okay, you can just mention it and we will be talking about that. But if everything is clear, that's gonna be great. Waiting for your reply again, and I'm going to continue the discussion. Okay, even I'm gonna solve it here, guys, on the screen. So if in case you will have any doubt or difficulty, you can let me know. So as per the spherical coordinate system, the Laplacian will be 1 upon r square delta upon delta r square delta v upon delta r. That's going to be minus rho upon epsilon naught. Clear? Now, rho is something which is already given, which is a upon r e to the power minus k r. Just put its value. So minus a upon r e to the power minus kr, that's what you are gonna have, and upon epsilon naught. Now what will be the next step? We have to simplify this part with this part. So what we have to do, r square, let's cross multiply it on the other side. So it's going to be delta upon delta r square delta v upon delta r. That's going to be minus a r e to the power minus k r, and that's epsilon naught. Now once again we will be removing this differentiation. So we have to take the integration this side, that this way. So let's remove this differentiation and let's take this integration. So dr I have to write here. You will be solving it by taking the first term and the second term concept. So first term as it is, second term integration minus first term differentiation, second term integration, and the integration of the second term overall you have taken. Okay, now this is how you will be able to get the r square delta v upon delta r value. Then shift this r square on the other hand on after simplification part. Then once again do the integration of whatever you will have the overall value and get the value of v. That's what you have to do. And I think after you will be solving it, you will be getting option B with this. But in case in calculation part or anywhere you're gonna have doubt, just mention it. We can talk about that too. But if it is clear, that's great, great, great. So let me know whether everything is all right and clear to you or not. If there will be any doubt you will have, we can surely talk about it. Okay, check out the calculation steps. I'm gonna wait for your reply for a few seconds, and after that I'll be going for the next question. We'll be giving you that. So let me know if in case you will have any doubt, any question, any query, or anything is not gonna be clear to you. We can surely talk about it. Did you get C? Vikram, check your calculation once again. I think you will be getting option B to be correct. You may have missed something. You may have made some mistake in the calculation of integration part or in the cross multiplication part. Check your calculation once again. I think it's option B you will get. And at the end, you also have to do one more thing. No, there is nothing like that. You just have to consider the dependency. See, are you getting r square in the denominator or just r? Along with that e to the power minus kr. You will have just this term there. Rest constants will be present, but you don't have to worry about the constants. Okay, check it out and let me know. Try and let me know, are you getting it or not. So I'm even gonna solve it. Okay, let's do it together. So when I'm gonna do this integration, it's first term as it is, second term integration, that's r as it is, e to the power minus kr, upon minus k, then minus sign. First term differentiation, second term integration will give me this one. Okay, that's going to be minus kr and minus k and dr. Now next we will be having is r e to the power minus kr upon minus k, then it's going to be plus e to the power minus kr upon k square, and that's how we have just considered this much part. Now next we will be having the other side. Did you get the same integration? Oh, that's great, Vikram. Done. And I didn't consider rest of the part, which is this and the other part. So you can take it in the next step and cross multiply the r square this side. So you will be getting 1 upon r square. Simplify it after doing multiplication. Then once again do the integration to remove this d by dr part. And once you will be doing that, then you will get the final expression for it, that what should be the correct dependency. Okay, that's how you can do it. Let me know if in case there is anybody having any doubt, we can surely talk about that one. Very good morning, everyone. Clear? If in case there is any doubt, even now anybody is having in getting the right answer, that's option B. You can let me know about it. But if you are getting it, that's great. We can go for the next question then. Tell me, tell me. Ready? Let's go for the next one. Any doubt? If yes, even you can mention it right now. I think nobody has mentioned it. But at any point of time, if you will have doubt, you can just mention that and we can talk about it. Let me just write the next question. Just a second. It's here. Our question is a constant electric current I in an infinitely long straight wire is suddenly switched on at t is equal to 0. The vector potential at a perpendicular distance r from the wire is given by vector A is equal to k cap mu naught I upon 2 pi log 1 upon r ct plus square root c square t square minus r square. The electric field at a distance. The electric field at a distance r less than ct is, okay, this is going to be ct. Clear? Is, if something is not clear, you can surely tell me about that. And the options are, I'm going to write them on the next slide. 0, the next one is mu naught I 2 pi t 1 upon root 2 I cap minus j cap. Next one is c mu naught I, and next upon 2 pi square root c square t square minus r square. 1 upon root 2 I cap plus j cap. And then option D is minus c mu naught I 2 pi square root c square t square minus r square and k cap. Just try it now and let me know what will be the right answer according to you. If in case you will have any doubt or difficulty, we can surely talk about it. But if you will be getting it, that's great. So you can start working on this part. And I'll talk about the steps too. The last one is r less than ct written there. Okay, try it now. We will be considering it that what is the right answer and what will be the right approach to work on it, but giving you some time to start working on the steps, and after that we will talk about it too. If anybody will be getting the answer, just mention it what is the right answer according to you. And if you will not be getting it, I'm gonna let you know about the steps and the process. If you want me to change the slide, even you can tell me that. I'm gonna show you the next slide in that case. Try, and let me know whether you are getting the answer or not. Its vector A is along k cap. Vikram, you can have a look at this. It's shown here, k cap. Vikram, just see, is your phone voice like the audio is full or not? Because I think my voice should be proper. But if it is not, you can check out your phone audio too. Okay, and it's going to be the k cap we are having here. Check it out. Because from my side, everything is alright and it should be the full volume you should have your side. Okay, okay. Check, guys, what will be the right answer according to you for this question. When you are having the vector potential A given to you and the details about the system have been given, you have to find the electric field. So check it out what you can do. So we all know that E is equal to minus delta phi minus delta A upon delta T. Okay, this is going to be the most important equation and you can expect the questions based on this equation in your other upcoming exams too. It is important for net gate test, TIFR and other exams as well, so you should have a good command on this equation. Now, since they have given you the vector potential and they have given you the information about the system, so for the particular system, like they have talked about, a constant electric current I in an infinitely long straight wire is suddenly switched on at t is equal to 0. So the vector potential at a perpendicular distance r from the wire you have to consider like it's given. So what you have to do in this case, the scalar potential phi will be 0. Okay, that's what you will be getting. So scalar potential phi is 0 means E is just equal to minus delta A upon delta T. So you just have to differentiate it with respect to T. When you will differentiate it with respect to T, what you have to do next? It's going to be 1 upon R Ct plus root C square T square minus R square along with the initial part. And then once again the bracket term which is in the log part, you have to differentiate it once more because it was the part of log and then there is T present. So you will be differentiating it again. So you will get C upon R plus, that's the square root part you will solve. it will be giving you same answer as given in option D. Please check it out once and let me know whether you are getting it or not. And the direction you can see will be the k cap direction, because the direction k is not changing there. So when it will be k cap, that's only in the option D you had, and also you will be checking out the expression. It should be similar to the option D. Vikram, Preeti, what do you think? Should I solve it once? I think both of you have got the option B. So just to confirm and to get it clearly like what it will be, let's do it together. Let's find the delta A upon delta D for this part. So when I'm going to do that, k cap mu naught I upon 2 pi. Okay, k cap mu naught I upon 2 pi as it is. Then log part is there. So 1 upon of everything which is already present, which is 1 upon r ct plus square root c square t square minus r square. 1 upon r ct minus or plus root c square t square minus r square. Then that's what you are going to have. And what you have to do next, you have to differentiate it with respect to t, because delta upon delta t you were solving now. So let's do the differentiation of this part. So we will be getting 1 upon r as it is. It will get cancelled out with this part. C plus, that's going to be square root. That is 1 upon 2. Okay, that is nx n minus 1. So 1 upon 2. The overall part n minus 1 means half root c square t square minus r square. That's what you will have. Clear? Now this is what you have got. Now next thing is once again the bracket part, the square root part you have to differentiate again. So what you will get from there, it will be 2 times the c square t. That's what you will have here. Okay, that's how you are gonna get it. Now let's take the LCM. When you will take the LCM, what you will be able to get, let's have a look at that part. 2 and 2 will get cancelled out. C you can take common. So you are getting k cap mu naught I C, and 1 upon r is getting cancelled out. So let's see what we will be having finally. Here I'm going to have c square root. Now I'm going to take c common to c square root c square t square minus r square, and that's going to be plus ct. Okay, and the LCM part which I have taken was, that's this denominator ct plus square root c square t square minus r square. Okay, within the square root, and that's it, bracket close. This is what we had, and the other square root part for which you have taken the LCM, this one I'm gonna note down in the denominator, c square t square minus r square. So this is getting cancelled out. I'm just gonna have, one time I have written c here. So k cap mu naught I c upon 2 pi and square root term, and the k cap direction is there. So you can see it's option D you had here, and that's how your option D is the correct one. Tell me if in case there is anybody having any doubt, we can talk about it, but if everything is clear, that's great. So is it clear that how you will be getting option D to be the correct one and not any other option? Done? Very good morning, Preeti. If in case there is something is still not clear, let me know. I'm just going to wait for your reply for some time, and we will be continuing the discussion after that. So both of you are getting the B to be the correct one, but it's not B, it's D. Okay, and the steps I have shown you, how you will be doing the calculation, what steps you have to follow and everything. If in case there is any doubt anybody is having, just mention it in the comments. Otherwise, we are going to go for the next question. Okay. Next one is here. 3 charges are located on the circumference of a circle of radius r as shown in the figure below. The two charges capital Q subtend an angle that's going to be 90 degrees at the center of the circle the charge Q is symmetrically placed with respect to the charges capital Q. If the electric field at the center of the circle is 0, what is the magnitude of capital Q? I'll be showing you the figure on the next slide as well. Okay. This is going to be capital Q here, capital Q here, small q here. The next is A option is Q upon root 2, B is root 2Q, and option C is 2Q, option D is 4Q. You're going to start working on this part and let me know what will be the right answer according to you. But in case if there will be any doubt you will have, we can talk about that too. Start considering the steps for it. Did you get option A? Very good, Preeti. That's great. So this is the question statement. Let's wait for others to reply too, and then we will be continuing the discussion. I'll be giving you the next question as well. So 3 charges, okay, are located on the circumference of a circle of radius capital R as shown in the figure below. The 2 charges capital Q subtend an angle that is 90 degrees at the center of the circle. The charge small q is symmetrically placed with respect to the charges capital Q. If the electric field at the center of the circle is 0, then what is the magnitude of Q? That's what you have to find. Clear? And in this case, what will happen? Here we are going to have the center. What we will do? We are going to consider that net field at the center is 0. And also, did they provide you the information about the radius? Yes, it's capital R. So in that case, if I'm going to consider the field due to this capital Q charge on the center, so it will be in this direction, due to this in this direction. So you can take their components in this direction, and downward direction. So downward direction components will get added, okay, and these opposite direction components will get cancelled out, and due to this small q it will be in upward direction. So K Q, and that's going to be the 90 degrees angle you are going to have there. If you will consider it this way, it will be 45 degrees you will have, okay. So sine 45 or cos 45, any component you can consider, because both are going to have the same value. K is for 1 upon 4 pi epsilon naught, Q upon R square, okay, and also cos or sine 45 degrees. So anything we can take because both having the value same. Also twice. Why? Because both the capital Q will have the filled in the same direction. And now the next thing is equal to k q upon r square. Simply, so r square cancelled out, k cancelled out, capital Q upon small q, or capital Q value you want to find. Yeah, capital Q value you want to find in terms of a small q. So you will be getting 1 upon root 2 here, that will give you root 2. So capital Q is nothing but q upon root 2. That's how you're just going to get, and it's your option A, which is the correct one. Let me know if in case there is anybody having any doubt, we can talk about it. But if it is clear, that's great. So you are having your right answer to be option A. Tell me, is everything all right and clear to everyone till this point or not? Done? If there is something not clear to you, or somewhere there is any doubt you will have, surely let me know about it. We can talk about that. Also guys, as you know that right now the latest offer which is going on Unacademy is just valid till 21st February, and in upcoming days so many new courses will be starting on Unacademy as well. Even so many new courses have recently started and going on Unacademy, which can help you a lot to take your preparation to the next level. You can take the Unacademy subscription. You can use and apply the code Anjali A Live to get the flat 20% off on CSIR UGC net subscription when the offer is going on. Even if any of your friends who are waiting to take the subscription, you can let them know about the offer and the referral code too, so that they will not miss it and they will be able to grab this offer as well. Okay, it's just for the limited period, so you can share this information with your friends as well, so that they will be able to get it too, and they will be able to do the best preparation under the guidance of top educators with the important sessions, courses, and the notes we are going to have. So these are the benefits you get if you take the iconic subscription. All the benefits of plus subscription will be included in this. Other than that, the rest of the benefits have also been mentioned in. And if you will be taking the plus subscription, then what are the benefits you will take? All that has been shown here on the slide too. Now what we will be doing, we can consider it this much right now. Okay, in the session, while we will be having the one more important session after this, so we will be doing the most important discussion there as well. Just in some time we will be starting that session too, so you can join that one as well. Let's keep it this much right now guys, and thank you so much everyone for joining this session. These are some of the important concepts we had from the electromagnetic theory part, and I hope each and everything we have talked about is clear to every one of you. If in case there is any question, query, or doubt you are going to have, you can surely mention it. We will be talking about those points too. So you can let me know if there is anything you want to ask regarding the questions we have talked about, or regarding what discussion we have done. We can consider that part then. Otherwise, we are going to keep it this much. And just in some time, we will be having one more important session here, which will be helping you to do the best preparation for your upcoming exam. And we will focus on the most important concepts, questions, and tips and tricks there in that session as well. Thank you so much everyone for joining this session. I hope each and everything we have talked about is gonna be clear. But anywhere, if you will have any doubt and you want to ask something, you can let me know about that too. And even in this question, if you have something not clear, doubt in the direction part, the formula, the expression, or how we got it, you can mention that too. Waiting for your reply, and we will be ending this session then just in some time. Okay guys, I hope each and everything is clear. In the next session as well, we'll be focusing on the concepts and questions both. Okay, and different subject sessions we are going to have now. So you can join all these important sessions so that you will not miss any of the concepts. Thank you so much everyone for joining this session and for attending it till the end. Thank you.